Hello guys, welcome back my dear students. I'm Dr. Haytham Asawi, physics teacher speaking to you. I hope you have enjoyed with your vacation and I wish you a year full of success and excellence. Hello guys, this is Dr. Haytham Asawi, physics tutor speaking to you. Today I'm gonna solve some questions about pressure from past papers, IGCSE 0625. But first, please don't forget to like, comment, share and subscribe my channel Lab Time Academy, and also you can click on the bell icon to get notification. Let's start. Question number 1. A large stone block is to be a part of harbor wall. The block is supported beneath the surface of the sea by a cable from a crane. Figure 2.1, this one, shows the block with the top face of the distance h beneath the surface of the sea. The force acting downwards on the top face of the block due to the atmosphere and the depth h of water is 3.5 times 10 to the power of 4 Newton. So now we have the force. So here we have the force. Okay. The top face of the block has an area of 0.25 square meters. So we have the area. He asked me to calculate the pressure on the top face of the block. What will be the total pressure on the top face of the block? Actually, you know that P equal F over A. Pressure is the force per unit area. So just write below P equal F over A. So here we have the F and here we have the area. So just divide 3.5 times 10 to the power of 4 divided by 0.25 equal 1.4 times 10 to the power of 5 Pascal. So this is the total pressure exerted on the top face of the block. Double I. The atmospheric pressure is 1.0 times 10 to the power of 5 Pascal. So here we have P ATM, pressure of the atmosphere. Calculate the pressure on the top face of the block due to the depth h of the water. Now he asked me to calculate the pressure due to the depth of the water, and he gave me the atmospheric pressure. If we return back to the diagram, here we have the block. Actually, we have very important question. I have to ask myself this question. How many pressures affected on the block? Actually, we have two pressures. The first pressure due to the depth of the sea, due to this height. And the second pressure will be the outer pressure, which is the pressure of the atmosphere. When we add the two pressures to each other, so now we can get what? The total pressure. So if I want to calculate the total pressure, just add the atmospheric pressure, which is the outer pressure outer the sea or the surface of the sea, plus the pressure due to the depth of the water. In the last question, he asked me to calculate the pressure on the top face of the block. This number is the total pressure. But in double I, he asked me to calculate the pressure due to this depth. So actually we have to subtract the total pressure minus the pressure of the atmosphere, so we can get the pressure due to this depth of the water. So now we can write here 1.4 times 10 to the power of 5, which is the total pressure. We got it from the last question, minus the atmospheric pressure, so we can obtain the pressure due to the depth of water. Triple I. The density of the seawater is 1020 kilogram per cubic meter. Calculate the depth h. Actually, all of you know that P equal what? P equal rho times G times h. Pressure equal the density times gravity, which is 10 times the height. So h will be equal to the P over rho times G. What will be the pressure? Actually, here we have to use this pressure. We have to use 4.0 times 10 to the power of 4 Pascal. This is the pressure due to the depth of the water. So we can't use the atmospheric pressure, and also we can't use the total pressure. Why? Because he asked me to calculate the depth h, so I have to use the pressure due to this depth. We got it from this question. So P equal 4.0 times 10 to the power of 4 divided by rho, which is 1020, times G, which is 10 constant meter per second square. So we can get 3.9 meter, which is the height of the water. B. Suggest the reasons why the tension force in the cable is not 3.5 times 10 to the power of 4 Newton. Actually, we have many factors that are affect on the block. We have the weight of the block and we have the upward force of water. The block is lowered so that it rests on the seabed. State what happens to the tension force in the cable. Actually, now the block is touching the ground, the seabed. So now this means that the tension force 0 or has the least value. So it would be smaller. So now we have become 0 or smaller. Two. A. Figure 3.1 shows an oil can containing only air at atmospheric pressure. Atmospheric pressure is 1.0 times 10 to the power of 5 Pascal. So here we have the atmospheric pressure, which is 1.0 times 10 to the power of 5 Pascal. Here we have P ATM. The pressure of the air in the can is reduced by means of a pump. You know, vacuum pump. And here we have a vacuum pump will be connected to this can. So the vacuum pump will remove all the air from the can. The can collapses. So the pressure on the air or pressure of the air in the can falls to 6,000 Pascal. The inner pressure will be 6,000 Pascal. Explain why the can collapses. Actually here, ya shabab, as I said, when we connect the can with the vacuum pump will remove all the air from the can. So this means that the outer pressure will be more than the inner pressure. The outer pressure, which is the pressure of the atmosphere, will be more than the inner pressure. So the can collapses. So he asked me, explain why the can collapses. Why? Because the outer pressure will be greater than the inner pressure. So the pressure greater on outside surface. Double I. The surface area of the face X of the can is 0.12 square meter. So here we have the area. Calculate the resultant force on face X when the can collapses. How can we calculate the resultant force? Actually, to calculate the resultant force, we have P, F, and A. We can calculate the F equal P times A. So F equal pressure multiplied by an area. The area is 0.12. But we have to get the pressure. How can we get the pressure? We have to calculate the total pressure. I said the can collapses. So this means that the pressure outside the can, which is the atmospheric pressure, will be greater than the pressure inside the can, which is 6,000. To get the total pressure, we have to subtract the outer pressure minus the inner pressure. So it will be 1.0 times 10 to the power of 5 Pascal, which is the atmospheric pressure, minus the pressure inside, which is 6,000, to get the total pressure. So this will be the total pressure, 94,000 Pascal. Now we can calculate the force by just multiplying pressure times area. The pressure, we got it here, 94,000 times the area, which is 0.12. So we can obtain what? We can obtain the force, which is 11,280 Newton. That's it. Thanks a lot.